Hello everyone, I'm engineer of Postgres professional, Andrei Zubkov. I'm responsible for developing of module for analysis of PG profile for NIL PG, also Pro PV for database, Postgres professional. We also here have some additional extension with additional metrics that Power can actually demonstrate. When we think about historical workloads, we usually think about analysis of productivity from the point of view of optimization. Or probably we want to inquire to certain incidents. As for incidents, I'm going to share a simple example, but as for the organizational issues, I will talk a little bit about that. As for optimization, that's what we do. First, we do assessment of the current situation, productivity assessment of database. Then we analyze the measurements in order to identify what needs to be identified. We also think how to optimize that. We optimize something, then we again take measurements, and so then we just see whether it actually doesn't get worse after that. Here we can see the functions and take sample. They are accumulated here regarding information regarding the productivity. Here we can see analysis parts and system for preparing reports. As for productivity, that's a very important issue. We have a lot of utilities used for that matter. For example, PG Badger is one of them that analyzes logs and journals, and it's written by Postgres, and it's very important to analyze them. But as for really loaded system, there might be a problem with the intensity of logging. PG Center works on dynamic presentation of productivity in a quite a prompt way. Here we can see a reflection of the resources, how they distributed, and then it's very important to say that here we can investigate certain problems that currently a database has. So, for example, in operating system, basically it has instruments to keep track of historical data, but it's not its main asset. PG Clue also takes certain past information and develops certain reports based on that. And this is quite an equivalent. Postgres checkup, this utility is used for analysis of the current databases status. And here it is done with a particular reference with the current problems or some problems that can appear later. It develops certain protocol with the recommendations, diary, so to speak. Very useful utility. POVA is another tool, something in the middle between monitoring and analysis of historical workloads, but with a particular interface, quite a convenient one. The interface still requires certain additional efforts during deployment. As for our PG profile is a little bit different from the above mentioned one. It's something that can be found on board on the airplane, very similar to these boxes. So what it's all about, it is located inside a database, unlike others, and quite often the profile is installed inside database. Well, it's good because it's a cross-platform one, and it has only Postgres, and it's the only thing that they need. And inside, so the database keeps track of all statistical data, index tables, statistics regarding functions, also trigger function, and also it keeps track of vacuum in index tables and general cluster statistics regarding database, table space, statistics of background writer, and some Postgres settings and some other administrative functions is also a part of this device. In order to understand how it works, I'm going to show you just a very simple example. Here we have quite a simple table, and here we have some identifier or some textual space that can be sent to toast. So here we have some data, and so we would like to work with some queries. But before we do that, we want to look at the statistics that is preserved in Postgres, and also what is read in this table. So we put it here so it can be visible for us, and let's try to do something about this table. For example, we here can trigger full scanning, and then we can see one sequential scanning. We can read some entries, and 192 blocks turned out to be in share buffers, and actually we received them from there. We already know something about that. So we know that this table is in share buffers. We didn't have to use disk to retrieve it. Everything is fine. And let's read something from toast. We're going to make another query, and so we can see according to statistics, so you have the time from the previous query, and we can see increments. And now we can see again persist scanning, and this points one of the blocks was read not from the file system but from the disk, and one from the toast. Very interesting. It means that there are not so many long entries there. Well, it's apparent what should be done. These statistics has to be stored somewhere, should be preserved, and all the changes should also be reflected. So later we can see what was happening in the beta later on. To do that, we are going to take some snapshots. Here we have a big explosion that is actually reference points, and time taken starts from this very point. And now we are taking shots, snapshots. Here we can see some statistics. And so we calculate increments of the statistics like just on the previous case, and based on that we identify objects that based on certain criteria generate the biggest loads for our database. We preserve and we keep these statistics in our repository, and then we will use it to make our reports. We're not going to keep information about all the conversions, because when it comes to optimization or incidents, we are particularly interested on something that creates the biggest amount of workloads. So we can see that here we can use Chrome. We don't have here an inbuilt scheduler, but we can use other means in order to still make those snapshots. Well, here we have a very interesting feature that tells us that if we want to get increment from 0 up to third snapshot, we only need to sum up all the increments between them, and then we will get the final increment. So why do we actually just calculate these increments instead of preserving just absolute value? Because it allows us just not to keep everything, because it's not needed, but it allows us to tackle the following problem. For example, we used to have a table A that was created after snapshot 0 and then was deleted after number 2, but we actually measure increments from 0 to 3, and if we have increments and we sum them up, everything is fine. Of course, we lost something here, but at the same time we saw that we had this kind of table and something was going on with this table. But if we preserve these absolute numbers, and for example we took them from 0 or 3, and of course we will see that there was no information about this table, and we could just simply skip it. That's why we prefer to store this increments. Architecture of this so here we can see this is we have extension PL or PGSQL that consists of different snapshots, some reports, and of course it's very nice to have a separate scheme for that. We also have the repository for all the snapshots table with information, and take samples, samples or snapshots. This is something that's used for accumulated all the samples, and get reports and get diff reports for working with reports. words. I will say a few words about it later on. And the function of data transfer, export data or import data. This is quite a new function that allows to accumulate data to get it from PG profile and take it from a different one. For example, when we have a certain database from a selected area, and we want, for example, if we want to export a file, then this supervision will be enough to do that, just to perform this function and then analyze that. How actually we take a sample or the snapshot. So we have a cluster or PG profile. This is actually where a profile is installed, and the monitored cluster we receive statistics from. Usually this is just one cluster, but since we can collect from different clusters, that is why we have this overall picture. Well, this profile has such a thing as server. So instance progress we are actually monitoring, and connection string also it's will open a profile with the first DB link installed in this connection stream, and from there, from DB link, it will receive information about statistics regarding clusters and also data that can be found in this cluster, and then it will use a separate DB link in order to retrieve statistics from them about databases. That there is no other way to do that. So then it will calculate increments, identify the so-called top objects, and after that it will preserve this information in these sample tables. Well, then the profile performs start statements functions, and since space is limited, it means that some objects are ousted from there, and in order to avoid relevant negative consequences, it's just drop start statements, and when it will come to the next sample, profile will assess actually how many statements have been accumulated there, and if it is very close to the higher threshold, so there will be a warning, and it will be reflected in the report, so that throughout reports periods state statements could be just be filled up to the point where some of them were retrieved from there. As for report, it is quite simple. We use get report function, then we set interval that we want to use in our report. It can be done in form of sample identifier or some time marks. If we use time, then there should be some monitoring function that is absolutely visible when we have the periods of anomaly workloads, so that we can generate reports on that.
So when we know time, we can try and make the report. So the interval expands to the nearest shots. For instance, well, the old report from node profile, but still we can take a look at how I was working on generating wall report. That's what it looked like. We had a Postgres DB, well, several databases that were working for 1S system, and unexpectedly wall started generating in a big amount everywhere, and it created a lot of problems in the backup server. And we had to figure out what was wrong, because 1S employees didn't confess what was happening. So you can see the timeline. 39 gigabytes in 29 minutes have accumulated. Maybe it's not too much, but it was too much for this database. So who or what can be generating wall? What's DML table? We are opening tables sorted by DML operations, and you can see 4 tables which are largest in terms of DML operations. So here we have 4 candidates for being source of trouble. You can also check queries, and you can take collapse time and can see the longest queries. You can't write a lot of data in a table fast, so we are checking the time spent. We can see the same table, 18355, which we saw right here, same table. So after that, we are showing this table to the administrators, asking what was happening. It transpired that they were uploading something there, and we asked them not to do this simultaneous on all the servers, and that's it. So what does a report look like of 031 version that will be issued by the time I present here? So server statistics, it's statistics for the whole cluster. So server statistics for cluster, SQL query statistics, that's what we are getting from the extension. That's is working on stat cache, pro stats, and other views. Schema object statistics, these are statistics on schema objects. Function statistics, it's for the functions, how much time they take, how they run, and trigger functions, what they look like, and vacuum related. That's all kind of report pages that are to do with vacuum. Database statistics. That's what we are getting from pages at database. Information on transactions, blocks that we read from the file system and from cache, a percentage of hitting the cache, tuples, what it was like, temporary file sizes, and last size and growth. Statement statistics is aggregated statistics from PGStat statements for different databases. Also quite a nice thing. The only thing is that the trigger field, it means that the time spent for trigger functions execution there, but it's not from statements, it's just from the table. And in version 13, we got wall size on wall volume generated by different expressions. So cluster statistics, a picture writer is about background writer, backend, checkpoint, and everything. It's a very simple report. That's why you have zeros everywhere. But in real database, of course, it'll look interesting. And here we have wall too. Table space statistics. Where the size, what kind of tables we have, and how they are growing within the specified time. Query statistics. Here we have different queries sorted by criteria. Each query has a link. You can click at it. You can see the query, and it's highlighted in the query table. You won't get lost in them. Elapsed time is total time spent for planning and execution. It's available starting from version 13 when planning is part of a statement. You can see time for planning for execution, I/O time if you are tracking that, CPU time if we have key cache available. And you can check the percentage of the total the time spent by this query out of total time spent by all the queries in this cluster. So that's how it affects our whole cluster. Number of planning, number of executions. Then planning time. If we want to check which queries are longest in terms of planning, and execution time. Elapsed percentage is the share of time execution of query takes out of total query time. So it's a share of execution and plan time. I/O time and query execution distribution time distribution. Top skill by execution, it's which queries are executed most often. Skill by I/O wait time, It's input output wait time. So we have read write. We have total time as percentage of percentage of total time, and splitting into query blocks. Fetch. The fetch here is means the sum of blocks received from caches and file system. So this is the total amount of them and percentage of cached queries. Then by sort report on reading. Share blocks dotted to check which queries alter blocks most. Share blocks written, it's on blocks that the statement had to send to disk on its own. By wall size, well, it's clear. Statements on wall, the generation on volume. But we also have stats on reads, records in total, and FPI image. There is no temp usage in this report. Our usage statistics. When you have cache of PGPro stats, we know how much time was spent during planning execution to execute this query. Also, we have information on read and writes from file system. It comes from cache or JPro stats. Total list of queries, but it's not really interesting, but you can click and get there to check the specific query. Schema object statistics. That's also sorted by different criteria. For instance, number one here is number of blocks received as a result of sequential scanning. Unfortunately, Postgres does not track the statistics, so that's why you have to do the mathematical calculation here. And that's how we get the tables in which we got largest of blocks generated by sequential scanning. Tables by blocks fetched. So here we have toast and toast index and so on. That's from cache and file system. That's file system only. DML operations, we saw that. So DML tables together with this toast, you calculate how many DML operations transactions there were. Interesting. 150 in the table and 750 in toast. It happens because the fields are long and they were split in toast. Next, updates and deletes. That's needed to check the adequacy of vacuum set and how it's running. So we can see the most active tables right here, and we can evaluate whether auto vacuum checks on them often enough. Growing tables. Well, here it's clear. The growing tables and DMLs running on them that led to this growth. Again, they are sorted by size and growth, and they are shown together as table and as toast. Indexes by blocks fetched. So same thing here. Indexes for blocks read. Tables and cache. Growing indexes. Fastest growing indexes. It's okay. Size as of the last image and growth within the report timeline, and additional DML operations. Unused indexes, they are indexes that were not scanned. You don't need to. We don't need this that often, but so we check that. Function statistics. Just by function, total time of execution, and the longest functions in terms of time are here by number of executions. And separate thing here is trigger functions. 1506 total time, you see, is the same time here in the aggregated table. That's the trigger function. That's here. Vacuum related is everything to do with vacuum. Tables are sorted by how often vacuum checks on them, and analyze operations, how often it is. Just FYI, maybe something is happening there that shouldn't be happening. Indexes. It's evaluating the load that's not obvious. The tuples ratio, it's a table as of the end of the interval, and it shows the tables with highest percentage of tuples with information on when the last time auto vacuum happened. Similar to analyze, but here we'll have modified tuples. Cluster settings during the report interval. This is the table which has Postgres parameters in course of our parameters. And if within the interval we have missed some parameters changing, there will be one parameter mentioned twice with two different values, and in the comments section or not section, time will be specified. Above we have not by default values, and here by default values. So that's the end of the report, and you can also check out the differential report. It's exactly the case when we want to compare two load intervals, like before optimization and after optimization, when we want to check how successful the optimization was. That's what it looks like. That's the heading of the report. But inside here, you would normally get two lines colored differently. On top we see the intervals. Here we also have intervals in the form of numbers, so you can point at number, you can see the time. And same stats as in the regular report, and you can easily compare. It's just, the rest is absolutely same, it's just you get the second section, which allows you to easily compare was and is. So I won't talk in detail because it's exactly the same. Right. Speaking about an obvious load on vacuum. Now, vacuum uses visibility map, and it's all fine. It doesn't check. It doesn't have to go through all the table, and it is checking the blocks that were changed. But index is not optimized in the sense, and vacuum has to scan all the indexes after scanning the table. And here there's this problem. If there is a big plot on index, maybe it's okay as itself, but it'll be bad for vacuum if it checks often. Because it can vacuum table fast, but it can really sync in indexes if indexes are to numbers. So that's how you can check how hard it is for vacuum. It's index size multiplied by the number of vacuums in the table. It was a simple table, 700 kilobytes. Indexes got to 200 to 300 megabytes. In itself, it's okay. But when vacuum has dropped by 621 times, so it creates a lot of load. it might not be the load on the file system, but still vacuum had to work very hard. And this kind of estimation or assessment is really good and really useful in terms of evaluating indexes versus vacuum. So the functionality of daily collection of relationship sizes, and it requires some special things, and blocking access share exclusive, and many things depend on the file system and so on. But and our engineers have suggested measuring these ratios once a day. And how it was implemented? It was implemented in the form of the window. We are deciding on the window when we can get this information, and there is a minimal interval set too. So once you're in the window, once we do our snap or image, then we move on. And if the interval is over, when everything's done, then we do not continue waiting for the next window. That gives us the opportunity to check all that when the users are asleep, for instance, doing it once a day. So that's kind of approach that can make it easier checking the other metrics, and some things won't be accessible if you don't have them. Export and import, quite straightforward. All the observations are being exported by default, but you can also specify the server name. You can additionally specify the interval from to, and if you really need it, you may limit queries by obfuscating it to avoid text of the queries or being visible to third parties. As a result, you get a simple table identifier and JSON, and it's wrapped in CSV, and that's it. You got CSV, and we send it where you need, and that's it.
So when you want to download it, it's pretty much the same. First, you need to create a table that has a very simple identification. You need here to actually use this export file, and after that, you need to launch this, run this function import. It will take everything from the table, and it will be sent to a repository where it can be collected and be used for reporting, just to see what's happened at different points of time. It's worth mentioning that when we do this and use this import function for the first time, of course, there will be some servers in the export file, but we really want the names of these servers to be really free in not in the cluster, but in the instance of the profile where we perform this import function, because it's not going to change just like that on the spur of the moment. And after the third import, then you can change the names, because then new data that will be inserted in the system, it will be identified both based on the identifier of the server and also the time of when actually the server was created, and deleted the RPG profile. Then you rename it, but still it will be findable. So quite a simple mechanism that allows us to keep track of different events. So expanded functions of power. We actually collect statistics regarding plans and statistics regarding expectation. I'm going to show you an example or report sample just to see how it works. Well, here, for example, we have statistics regarding database. And here we can see aggregate statistics regarding expectations, regarding database, and regarding types of, this expectation, how time was there. I mean, weighted time. And so we can see here we have a PG Prostat, and here we have a sampling approach. And then in aggregate way, we take it from this table, and as for here, this part here, we can see different types of weighted time and specified time, how we had to wait it during the reporting period, and also total amount. Here, every query has a plan. Here, query plan, and for this plan, we have different types of statistics. So all the tables, they are absolutely the same. A plan is also here. Here we can see a query, and we can see a query and a plan. Yes, it's not very visible, of course. Yes, because sometimes it's too heavy. Yes. What else? Here we have also statistics regarding the weighting criteria. Can be seen here. Here we have query and plan. First, function weighted, total amounts, details. Regarding this weighted column, and here you can see that. In vlog, we can see query is based on this plane. As for weighted, it was 4.5 seconds, which was 70% of all the amounts, weighted criteria for all the clusters, and details. Quite useful interface. Apparently, from there you can jump directly to the part just to see what kind of query and kind of plan we had here. As for power, that is basically is. So I think that in future we will have some additional statistical data here, and it's gonna be very useful in terms of information that it contains. So what kind of complexities we have? I mean, outstanding complexities. Well, first we need to have some issue with the sizes or dimensions of the relations. Of course, we're trying to figure out what to do with all those blockings and how to simplify the whole procedure. But still, there are a lot of outstanding questions, which is a little bit weird, but still. Then encoding of reports. Yes, we use SQL. It is done on the server, and then customer received it in some local codes. And of course, it needs to be reflected in reports. And when we have HTML, it's not quite clear. We also need to do about something about codes between SQL and interface that can receive through SQL, and also codes that can be reflected in HTML. So we still have this problem with coding, and we need to change it in the browser dependent on the coding system of the customer. Again, I'm talking about the symbols and general problems with statistical data of Postgres. The point is that sometimes statistic goes to some stats pool, and when we look at this, yes, we understand that we can work with statistics in different ways. And, you know, if we do just with a period of 24 hours, then it will only be taken into consideration based on the very last sample. Sometimes it turned out that we had some statistics, but there was none on the last sample. So it means that there was just 24 hours between the two, and there was some problems regarding the monitoring of these changes. There are some issues in Postgres, but we are working on that, and of course we have a plan to expand this statistics pool. That is basically it, and here are some links, PG profiles and PG Pro Power presentation. You can follow this link if you want to find out more about it. That is it, and I'm ready for your question. Great. Thank you very much, Andrei, for this information. And our speaker has just joined us online, and he is ready to answer your questions. I would like to remind you that you can ask your question in our chat. And the first question is from Mr. Marichoko. So, speaking about statistics, there we have only top level queries, but also those taken from PBSQL functions. Well, you see here it is pretty much similar to different extensions, and for example, PG Prostat. We also have NetStat statements. So there we have the same rules, regardless of the settings. The point is that if you choose all, well, that we will be able to see all the queries also in the function. But so far, well, at least in function 14, it will be corrected. So far, we cannot see, cannot correctly estimate this total percentage, because we do not really know how many resources were spent within the scale of one cluster, because here the same load was estimated several times. Okay, great. And here is the next question for you. What load is generated by PG profile for the system during the snapshot? This is a very good question. I don't have load is really big, but I don't have one single answer to that. The point is that the load that is related to snapshots, it is actually used also for developing this top objects list, and it's not that simple. Why? Because we use different criteria while choosing objects, and the point, in order to identify top queries, we also have to perform some functions and to do some actions, sort out information. And for example, we have 10,000 of them. They have to be sorted out several times in order to identify those that be classified as top queries. It is also related to data base objects. They can also be sorted out based on different criteria. Well, that is actually explained by this very fact. And we have also some additional problems which are related to, I mean, all those dimensions, sizes of relations. We're trying to understand what can be done about that. So we are now in experimental mode, and of course we try to do some estimations, but there are certain aspects to be considered. So the point is that we, for example, might have some indirect loads linked to the load that goes to the vacuum. For example, this particular snapshot, we know that we had this kind of vacuums per table, but we don't know the size of the index. It's very complicated. Here we have linear extrapolation. Well, anyway, we are trying to switch between different possible solutions, but still we have quite an issue with this one. But in the profile we have a special time measurement mechanism, quite a detailed one. It is switched off by default, but in the documentation you can see how it works, and there it actually can give information how much time was spent on that on this snapshot, and also provide some additional data also regarding these relations. One more question. Are there any limits or limitations for statistic storage? We can work with parameters on our own. Profile has that. For example, are we talking? Yes, we're talking about top values, because we have a first parameter about top objects on the snapshot, and another parameter which is about time for storing all this stuff. Yes, so when actually a snapshot is taken, it analyzes just to see whether it is performed as for longer storage periods. We can set certain intervals. For example, I want to store this information forever, or for example, it should be kept within a period of 2 months. You set certain parameters, and then it just follows your instructions. So next question. codes, please say what the print is. Shift lifting. The LibreOffice. We have source prot medium or something like that. So next question from Maxim Sherstuk. There is such a way of monitoring, but the solar ring, do you know anything about that? And you do know about that. It can be compared to PG profile and PG Pro power. Well, you see, unfortunately, I don't know. Okay, I just noted it down and I will take a look at this. Well, you know, this is just commercial stuff and quite expensive. And of course, it should be better. We expect it to be more expensive because the special solutions are linked to the database. Of course, it's supposed to be better. But what about this situation? Yes, so there are always pros and cons. PG Profile and PG Pro PVR, it was developed in order make Postgres move closer to enterprise, just like Oracle. We have, for example, database. Yes, it works, and it's enough for us to know what's happening there, so that we don't have, to use any additional elements. The idea is that, for example, I don't have a specialist who would be responsible for installing some external web servers just to go into web's database to show some beautiful pictures. No, I just want my database to give me full-fledged information. Simple thing where you only need cron to work with this data. And so we know that it can all be retrieved very easily. Of course, it's not as functional as some external device that can be do whatever you want. Yes, to be connected to anyhow you want, but at the same time there is certain advantage that you don't have to take anything from outside to make your base function. Thank you very much. I got your points. I didn't notice. And do you have a report regarding the waiting times? I mean, for the queries and not stations. So the question SQL, IT, and P, are they linked? So there is just like and the stat statements, planes and waiting criteria. So we have the statistics. Statistic is the same as and stat statements, but also just as weighted criteria. We also collect something that's caught by PG Prostat. The point is that there we have a certain feature that will be able to display information based on aggregate sessions and also hosts where this was received from. There, of course, will be certain aggregation regarding this weighted column, but it's so far hasn't been done, but this is one of our perspectives. As for sessions, I wouldn't say so because it's not quite clear how to do that. The idea of the mechanism is that we work with accumulated stats and snapshots, but it's not done that often. Oracle, for example, does it only once an hour, but still it's enough to identify some big problems in the database and to work with the system. And I would say that we can really identify some basic problems with the help of that approach. But as for sessions, well, if we just take snapshots once in half an hour, we cannot just catch it. PG Prostats cannot keep track of that. It should be stored somewhere. Moreover, yes. Next question is from Maxim Yurievich Rostuk. So he is asking whether you can use analysis for production. I have already answered this question. As for production, it is used there. And speaking about generation, it was used there. As for indices that can generate real loads, yes, it was also caught. As for load, is quite moderate, and major problems related to taking snapshots. It's all about the size of the relations. If you, for example, can see that snapshot can be done within 5 seconds once in half an hour, that's not going to generate too much load for your system. And even yes, once in half an hour. But as for the same main breaks, it's all about relations and the size of these relations. And for example, if you can see it in detailed information about snapshot timing, then you will be able to make a certain conclusion. But I would like to see how it works. So far, it has only been written, and would be nice to really give it a try in practice. As for the rest of the issue, this load is quite moderate because snapshots are not taken that often. Great. We also have some more questions. The next question is from Alexander Nikitin. Do you have any plans to use data that can be provided by PGStat Monitor Procon? PGStat monitoring is an interesting thing, but I have already considered that, but I'm still thinking about it. Yes, there are a number of features that have to be considered. We have to understand what can be taken from that, and at the same time, we also need to understand whether we will definitely need it or not, and to what extent. And of course, to do that, we should wait a little bit for Stat Monitor to become some kind of a standard where it could be seen in some systems, and of course, the profile could also see that if you do it just for 2 or 3 persons that could use it for some sake of experiment, that's way too expensive, you know. But if it turns out that it is quite interesting for many people, we could really give it a try. Next question from Alia Dave. What about data and how it is accumulated at the level of waiting time for snapshots? It's only possible to do that with PG ProStat, Postgres Pro. Here we use a mechanism, use sampling. It can be adjusted, there can be used, and we can use this extension PG ProStat, how it works, how PG Progress Pro works. Yes, it is done there. Progress Pro. Now the plan, and also use weight sampling on vanilla Postgres, but it hasn't been done yet. So Sergei Petrov is asking you, what about the size of a relationship? Is it done together with forks? Have you ever tried to use the size of files to do that? Yes, it's done with indexes, but without forks. Well, as for file size, it's not so that easy to do. I mean, it can be done with the help of PGSQL. And basically, I would say Postgres still doing that. It blocks it and then measures the size of the file. I would say that here we don't have any simple ways to use PGSQL to measure the size of the file, and moreover, it also cut down on the cross-platform function because it also depends on how we are going to use our instruments to analyze the size of the file.
Sometimes it just drops. So there are difficulties, and it would be nice to have Postgres function working well enough, but we're not going deeper into it. Thank you. Next question. Can I install the profile to the remote server and doing the screenshot in the remote server and check the snapshot here? Well, if you can connect there, yeah, of course you can install there. For that, you need to place a script file for extension enrolling. So you install it there, make snapshots there, and to check the HTML, you need SnapSQL, and or you can make snapshots. So you can make snapshots there and upload it to your local place, or you can do it on your local machine, so the way you want it. Great. The next question, repetitive question. I want to specify my question. I need the report on the query history without the waiting for actual history. So this is a question that is related to the question, to the previous question. SQL and PIT connection. I don't know, it's confusing. Yeah, we'll be thinking about it. As of now, we don't have this functionality, and it's something Nikolai Samkholov was talking about. There is a gap between we have in query groups received through the statement or and by searching the specific query according to some certain parameters, who invoked it, and so on. As of now, we don't have this opportunity. And the next question, the last question. The interface being very limited is your choice. Well, HTML for PSQL is, well, of course, it's doesn't have any extra frills. And we were considering, well, having the tables so that can be sorted by, but it would require a lot of things. So you cannot sort by anything if you want to get adequate data and so on. As of now, yeah, but you haven't seen the Oracle. It's, well, you can add some niceties and some tables, but eventually, yeah, you don't have much freedom to be nice and having decorations.